Why Earth is the only place in the universe with fire that is not available anywhere else? You heard right. So far, except Earth. Scientists, no fire detected elsewhere in the universe. Now you might be thinking, what about the Sun? Planets believed to have fire. Or there is a volcano. Even a planet with violent lightning. How can we be sure that there is no fire elsewhere in the universe? But the reality is, these phenomena, strictly speaking, it was not a fire as we normally understand it. So what is fire? Some people think fire is plasma, and the fourth child of matter. If you use an object with static electricity near the fire, the flame will twist and turn. This proves that there are indeed charged particles in fire. But does this mean that fire is plasma? That is not necessarily true. By comparing fire on Earth with fire on the International Space Station, you will see that the latter has a strange spherical shape. Why is that? We all know one thing. The hottest flames are usually blue. So where does this blue come from? There is something even more wonderful. Some flames are almost invisible. Since humans learned to use fire, it has thousands of years of history. But many mysteries about fire remain unsolved. So the fire we see every day, what the hell is he? Why does it seem to only exist on Earth? What is his relationship with life? Anyone who has ever been to school knows fire is the product of the combustion of fuel in the presence of oxygen. But fuel, it is not limited to substances like gasoline or diesel. In fact, any flammable substance, whether it is wood, paper or cloth, can be considered as fuel in the presence of oxygen. Usually refers to atmospheric oxygen. But some fire, even when there is no oxygen in the air, he can still burn. For example, chemicals called oxidizing agents can directly support combustion without the aid of oxygen. When we say something is burning, what really happens is that fuel and oxygen, rapid chemical reactions between gases, releases a lot of energy. The main form is heat. But even if you put something flammable and oxygen together, maybe it doesn't catch fire. Fuel must reach a specific ignition temperature. It will catch fire. Each material has a different flash point. The temperature must reach the ignition point. Fire can burn. So you always have to use the match at the beginning. Lighters and the like. Once the combustion process begins, the heat generated by the fire will continue to attack remaining fuel. Keep the fire burning. So, fire needs three basic elements: fuel, oxygen, and heat. These three things are often referred to as the fire triangle. Fire safety training at work. You may have seen this diagram. Remove any element. The fire will go out. For example, using water to put out a fire is a fire blankets are used to isolate oxygen. Remember this knowledge point. It will be useful later. First, let's talk about fuel. Fire on Earth. Most of what is burned is organic material. To be frank, it is something that comes from living things. For example, gasoline, diesel, this is a fossil fuel. They are all created from ancient creatures. Wood, paper, and fabric are derived from plants. Even materials like plastics and synthetic fibers. Its origin is mainly petrochemical products, also based on fossil resources. Let's talk about oxygen. In the early days of Earth's formation, there's no oxygen in the air. Initial oxygen. It is made up of a species called cyanobacteria, produced by bacterial microorganisms. All the oxygen in our atmosphere today may be derived from the activities of some living organisms. Simply put, to basic components of fire. Fuel and oxygen. They are all products of life on Earth. In a sense, why fire can exist on our planet. The root cause is on Earth, existence of life. What about the rest of the universe? Does this mean that only life can produce fuel? Not so. There are many non-biological fuels in the universe. For example, methane. This stuff is widely distributed in the universe. It is also a great fuel. Saturn's moon Titan has large amounts of methane. It has also been found on other planets and moons. But there is a lack of oxygen on Titan. Even with enough fuel, there is still no fire. Suppose that oxygen arrived on Titan by some natural means. There may be fire. But this fire will not continue. Oxygen or anything combustible will be depleted, and the fire will go out. Some celestial bodies in the universe, there may have been fire in the ancient past. But if fuel and oxygen are all exhausted, then the fire was also extinguished. So today we can't see anything. But on our planet, those are two completely different things. Fuel and oxygen are essential for life, continuously produced by life. Microorganism tree, especially the photosynthesis process. Besides, there are also countless fuels like firewood, coal, major fuel sources such as paper and even cloth. Even animals. The energy stored in the body ultimately comes from plants. So fossil fuels from ancient animals. Its energy can also be derived from plants. Plants use minerals in the soil, water and carbon dioxide in the atmosphere, solar-powered organic production, and in the process, it continuously releases oxygen. Can be understood simply, fire can exist on Earth is because solar energy is continuously absorbed by life and converted into fuel and oxygen. Therefore, it is life that keeps the fire burning on Earth. We are not there yet. Finding life on other planets. This may be why we also. Second planet with fire has not been found yet. Although we often hear that the sun is burning. But the fire in the sun, not the fire we usually talk about. The sun is rich in hydrogen, But hydrogen is flammable. But fire needs oxygen to burn. But the sun has no oxygen. The sun's energy does not come from burning hydrogen. It comes from nuclear fusion. In the core of the sun appeared hydrogen nuclear fusion reaction. It releases a lot of energy. This synthesis reaction only occurs deep in the core of the sun. The energy it produces does not come directly to us. Let me put it this way. Objects glow when they are extremely hot. Like a filament in a light bulb. This light is emitted from hot objects, called thermal radiation or blackbody radiation. The powerful effects of nuclear fusion in the sun's core. The scorching outer layer also becomes extremely hot. Make the sun shine. That's why. Sunlight does not come from fire. The sunlight we see, and the light of other stars. This is radiation. When a volcano erupts, it looks like a fire is breaking out, but it's actually lava. Boiling rocks and mud. The light on the surface is not fire. That is the thermal radiation we discussed earlier. In rare cases, when the volcano erupted, some of the released gas reacts with oxygen in the atmosphere. Contact with gas may cause fire. Create fire. But it still depends on oxygen in the Earth's atmosphere. Now let's take a closer look at the fire. Why are some flames blue, while others are yellow? Is this flame plasma? Why does he look like that? We said it before. Fire needs fuel, and oxygen is a product of rapid chemical reactions. The main byproduct is heat. Only when this thermal energy is converted into visible light, we can see the fire. If heat is not converted into visible light, although the fire is burning, but it may not be visible to the naked eye. This is what is called the invisible fire. First of all, how does heat become visible light? There are several ways. First, let's talk about the yellow flame. Remember the black body radiation we talked about earlier? Conventional fuels such as wood, candle or gas, composed of compounds containing carbon and hydrogen. During combustion, they are usually converted to carbon dioxide and water vapor. But in many cases, incomplete combustion leads to small carbon particles, but still in flames. In the incomplete fire, contains a lot of ash. The particles are heated to high temperatures and emit light. This is the yellow flame we often see. So the typical yellow flame, it was actually a pile of burning coals and is glowing. Let's talk about blue fire. If the fuel is burned very cleanly, no carbon particles left behind, flames are usually blue. This blue radiation is different from black body radiation, but from the emission spectrum of some molecules in a flame. They emit light at a specific wavelength. When the element is heated, its electrons absorb energy and jump to higher energy machines. When the electron falls back, a lot of energy is released in the form of light. The color of light depends on the energy difference, unique to each element. This is the emission spectrum of the element. Molecules and compounds also have emission spectra. When fuel molecules burn, will be divided into smaller components, called free radicals. These free radicals also have their own emission spectra. The emission spectra of some free radicals are located at blue region of visible light. This is the shade of blue flame. Simply put, the color of the flame depends on whether it burns cleanly or not. What is burning determines the color of the flame. So you see, to make the fire visible, heat generated from fire must be converted somehow into visible light. Otherwise, even if there is a fire, we cannot see it. It is the invisible fire. Like burning hydrogen, methane, and alcohol. The fire is very weak, almost invisible. In spite of, maybe I saw a little light. Why do flames on Earth always point upward? This is due to the combined effect of the Earth's gravity and atmospheric pressure. When the air in the flame is heated, it will bloom. At the same time, the density will also decrease, and forming airflow, run up gently. Cold air beside it quickly flooded in from below to fill the gap. It also brings new oxygen to the fire and make the fire burn stronger. Hot air rises, make the flame last longer, and it also takes away emissions. But in microgravity, for example, the International Space Station, hot air does not rise. The fire turned into a round ball. Exhaust gas after combustion is not easy to escape, all piled up beside. The fire may go out by itself after a while. Finally, about the question, is there plasma in the flame? When the temperature is extremely high, usually more than 3,000 degrees C, atoms in matter can lose electrons, become an ion, formation of plasma. When we burn wood, the temperature difference is negligible compared to a candle. Even the flame of a gas stove is only about 1,500 degrees. So there is no plasma in these fires at all. But in the chemical reaction of burning things, fuel will crack, turn into some small pieces, free radicals. Some free radicals are electrically charged. So with special power plant equipment, create this fire. But this does not mean it is plasma. Of course, some fires can be particularly intense. For example, oxyacetylene welding gun. Temperatures can exceed 3,000 degrees. This extremely high temperature flame, it can actually create some plasma. But even so, only a small part of the flame is plasma. Not all of them. Overall, scientists do not consider fire is defined as a single form of matter. This is a dynamic chemical reaction process. Instead of asking what shape fire has, it is better to understand that fire is a phenomenon or a process. A process involves the interaction of many forms of matter, effects and transitions. Fire, this seems normal, but is a real phenomenon that contains the mysteries of the universe, the mystery and miracle of life. Today we revealed. It was just a glimpse into his mystery. From the uniqueness of Earth to the vastness of the universe. From microscopic combustion to macroscopic stars. The exploration of fire never ends. I hope this little discussion. May your love for the unknown world be ignited. About fire.